Okay, so the next thing we need to understand is the relationship between the correlation coefficient R and the coefficient of determination. So the coefficient of determination is R squared. The correlation coefficient is R. So how do you think they're related? Just take the square root of the coefficient of determination, R squared, and guess what you're going to get? R, the correlation coefficient. That is how they are related. So let's think about in terms of what they mean. So we already talked about the coefficient of determination, right? It ranges from 0 to 1 with a higher value indicating that our model fits the data better. And in fact, we found the value to be 0.9027 in our last video. So basically what that means, like the interpretation of it, is that 90% of the variability in our outcome variable in Y is explained by our regression model. In our variable we had, or excuse me, in our model we had X, which was the student population size. So by just using that one variable, right, in our regression model, we were able to explain 90% of the variability in our outcome variable in Y in sales. So that's the actual interpretation of that. So with the correlation, right, it measures the strength and direction of the linear relationship between two variables X and Y. So the correlation coefficient, it takes on any value from -1 to 1. So remember, coefficient determination goes from 0 to 1. Correlation goes from -1 to 1. So it indicates the direction of the relationship. So it says whether the relationship between the two variables is positive or negative. With our correlation, or excuse me, our coefficient of determination, it does not tell us the direction. However, the correlation coefficient does. It does indicate the strength of the relationship, where it's stronger if it's closer to -1 or to +1. So they both tell us something. They're both related in terms of how they're calculated. So you can definitely look for those when you're looking at the simple linear regression.